Welcome, class. We're doing a lesson on something called Hess's law. Now, Hess was a chemist, and Hess wanted a little method by which he could figure out the heat of reaction for a reaction that had been never studied in the laboratory. Now, it should make sense to you that we can't possibly run all possible reactions and calculate their heat of reaction. But it turned out, Hess realized, that if you found other reactions that had the reactants and products that were involved in the unknown reaction, you could rearrange the other reactions in such a way, through adding and canceling, that you actually could recreate the desired reaction. And once you did that, you could take the heats of reaction of the known reactions and simply add them up to equal the unknown. Now, it could happen, guys, that these already might be rearranged, in which case there would be no changes to make, and you would simply add up those two numbers. That's possible. Is it likely? No. Would you see it on a test? No. But I do want to tell you it's possible. Well, what am I looking for? Well, I know that I need to have 4 PCl5 gases on the reactant side. I need 1 P4 solid on the product side, and 10 Cl2 gases on the product side as well. Well, if you notice in the first reaction that I gave you, this is why we chose this reaction, because it has PCl5, and notice it has PCl5 on the reactant side. There is one problem, however. I only have 1 PCl5 gas, and I need 4 of them. So what do you think I have to do? I need 4. I only have 1. I need to multiply everything by 4. That's right, class. I need to multiply everything by 4. 1 times 4 is 4. 1 times 4 is 4. 1 times 4 is 4. Ah, and don't forget, my friends, you therefore need to multiply that negative 2439 by 4. Let me do that right now. 2439 times 4 equals 9756. Negative 9756 kilojoules. That's a typical move. You might have to double something. You might have to cut something in half. That's, again, very, very typical. But this is interesting. I need, as I said, 1 P4 solid on the product side. And if you notice, I have 1 P4 solid, but it's on the wrong side. What should I do to the formula? To the reaction, I should say. It's on the wrong, yeah?
You can reverse it and then subtract and negate
Yeah, perfection. Guys, what we want to do, we want to rewrite this. So can we do that right now? We need the P4 on the product side. We need the 4 PCl3 on the reactant. So I'm going to reverse the reaction. PCl3 gas, now that is on the reactant side. Again, I am reversing the reaction. The P4 solid is now on the product side where I need it. And of course, don't forget, you have to bring this 6 Cl2 gas onto the product side as well. Now, it's very important, my friends, that you do this. Once you reverse this, you need to cross out the original, or else you get very confused. Also, Miguel correctly said, I need to reverse the sign of this. In other words, I have to multiply whatever this is by negative 1. Negative 3438. Because we were so careful here, and I think we made all the right changes, I think at this point, we simply could just add up altered values 9756 and 3438. But before I do that, I want to make sure, I want to verify that everything that we did was correct. And I do it this way. I want to make certain that these are actually combined correctly into the desired formula. I'm going to do that by doing two things. If two things are on the same side, I add them together. If they are, however, on opposite sides of the reaction, they cancel out. Notice, I have PCl3 gas, 4 of them, on the product side. And I have 4 PCl3 gas on the reactant side. Notice, Mr. Reese, they're on opposite sides, so those cancel out. Why is that important? Because I don't have any PCl3 gas in the finished formula. Now, we had those things that cancel out. Now notice this, Miss Patron. I have 4 Cl2 gas on the product side and 6 Cl2 gas on the product side. They're on the same size, so I add them together. Now, Patron, what's 4 plus 6? Yeah, oh, look, yay! So that verifies, that's where I get the 10 Cl2. And notice, I have 4 PCl5, just where I need it, and P4 solid, just where I need it. So that verifies that everything I did was right. And now I can go ahead and I can add together the negative 9756 and the negative 3438 and get negative 13,194. And I would say, again, that that is a middle-of-the-road kind of question. It's very typical, where maybe you reverse something, maybe you multiply something by 2, maybe you cut it in half, something like that. What do you think? Does that make basic sense at this point, the approach? Okay. But guys, again, it's a little bland. It's time for some spice. Spiciness. Guys, I teach you a spicy one because I want you to be able to handle the spicy ones. But believe it or not, the approach is always the same. Ooh, 7:47. I have half my time done. P2. Darn it. Okay. Same approach. Number 2. We have this reaction. I do not know the delta H for this. I'm going to change these, or maybe leave them the same. And I'm going to then add together these 3 delta H's once I've made some changes. Well, what do I need? I need to have CO2 gas on the reactant side. I need 1 carbon solid on the product side. And I need 1 O2 gas on the product side. Oh, guys, can I recommend something to you? Oxygen. If you notice, I have oxygen in the first equation and in the last equation. I beg you, don't try to say, oh, well, if I need 1 O2 there, and don't play with those numbers. You'll drive yourself mad. Just save the oxygen for the end. Oxygen will take care of itself. Start with an easy one. O2. Notice in the third equation, I have 2 O2s, but notice I only need 1 O2 in the finished equation. What did I say? See, oh, sorry, see? I fell into my own trap. Oh, dear. Thank you, Miguel. 2 CO2s. I only need 1 CO2. So, class, what is an... Yes? Is it an emergency? Because I don't want you to miss this. We can hang out for it. I appreciate it, just for your sake. Thank you. Guys, what change do I have to make here? Yes. Divide by 2. I'm going to put it this way. I'm going to multiply by 1/2. So class, what's half of 2? 1, very good. Half of 3? You can say 1.5. I'm going to do fractions. I'm going to say 3 halves. Of course, you can say 1.5 if you like. Half of 1 is a half. Half of 7 halves. This is actually the nice thing about fractions. 7/4. Now, you want to multiply then this by a half. So 3511 is 17. Let's make it 1756. Okay. That's not so bad. Carbon. Oh, take a look, guys. I have 1 carbon and I have 2 carbons. I need 1, I have 2. So what do I have to do to this equation? How about Ali Patron? Ali, I only need 1, but there are 2 in that equation. What do I have to multiply this equation by? Exactly. Half of 1 is a half. Half of 2 is 1. And half of 3 is 3 halves. Okay. Multiply this by a half. 190.6. 190.6 divided by dose 95.3. Okay. This is again, this is easy. This is just like the other one. Here's where the trickiness comes in. That's all the changes I can make. In fact, I'm pretty sure that I've made all the changes that I need to make. But notice a problem. This may have occurred to you already. I have an H2 in this equation, and I have 3 halves H2 in the second one. Guys, I don't have any H2s when I'm all done. These have to cancel out somehow, but notice if they're on the same side, they add up. So I have to reverse one of these reactions. It can't be this one, because I have carbon right where I need it. I have to reverse this equation in order to get H2 on the side so it can cancel out that one. So we need to rewrite this. So if we could, H2 gas plus 1/2 O2 gas yields H2O liquid. Then, guys, extremely important that you go back and you cross this out. Get rid of it. So that's reversal. Also, guys, notice I have H2. I'm going to need to get rid of that 3 halves H2. So I need to multiply this by 3 halves. See, this one is a spicy one. So 3 halves times 1 is 3 halves. 3 halves times a half is 3/4. And 1 times 3 halves is 3 halves. Now, you have to keep track of everything. You reversed it. That means negative. You multiplied it times 3 halves, so 3 halves. So we have 643 times 3 divided by 2. So that's going to be a negative 964.5. Okie dokie. You'll add those up then. Oh my goodness, I have just enough time. Let me show you how everything cancels out then. Notice I have no waters up there. Why? Because these 3 half waters cancel out these 3 half waters. I have no H2s up here. These 3 halves H2 cancel out these 3 halves H2. I have no C2H6, but this C2H6 half cancels out that one half. Okay, and to our viewing audience at home, just you're going to add up those 3 H's. I have to end now. So goodbye to the viewing public. I just ran out of